Hello everyone. So today our topic of discussion is the binocular cues, also called the physiological cues. These cues to depth perception in the three-dimensional space are provided by both the eyes. Now coming to the first one, which is the retinal or binocular disparity, which essentially is the difference between the two images. Now the difference between the two images, it occurs because the two eyes, left and the right eye, they have different locations in our head. Essentially, both the eyes are separated from each other horizontally by a distance of about 6.5 centimeters. And it is because of this distance that the image which is being formed on the retina of each eye of the same object is going to be slightly different. So now basically the brain is interpreting a larger retinal disparity or a larger retinal difference pertaining to objects that are being viewed at a closer distance. So the objects that are closely placed, the retinal disparity is going to be larger as compared to objects that are far flung or farther away from our vision. So, for instance, let us just do it at the moment. Let us try doing it right now. So, let us just shut our left eye, and with the help of our right eye, let us view any closely placed object. You know, and now let us shut this right eye and view the same object with our left eye. You will see a difference pertaining to the object that is placed very close to your eyes. You will see a difference in the image being formed on the retina of both the eyes. Now, if I try to do the same experiment, viewing an object that's far flung or farther away, the retinal disparity or the retinal difference will not be that much. But in case of the close objects, definitely. The difference in case of both the images will be there, and it's quite large. That is what is the retinal disparity or the binocular disparity. Now, moving on, of course, to the next topic, which is our convergence. Very, very interesting. So, when we talk about convergence, it is all to do how, when we try to look at any nearby object, we see how our eyes are converging inwards, literally, in order to bring the image on the fovea of each eye, right? So basically, when we try to focus on images that are probably less than 4 to 6 meters away, the eyes are going to turn inwards to focus on the same object rather than moving together. The angle the eyeballs turn towards each other probably is smaller when the object in focus is farther away. So we have observed this many a times, that how when we try to focus on objects which are very close to our eyes, how our eyes are turning inwards, and as and how it begins to move away from our eyes will stop converging. The convergence will, of course, but decrease, isn't it? So what's happening is there is a group of muscles that send messages to brain regarding the degree to which the eyes are turning inwards. And these messages are actually nothing but cues, basically cues to the perception of depth. Now, the degree of convergence is definitely going to decrease as the object will begin to move further away from the observer. We can try and do an experiment for this, which is very clearly visible on the screen, which is given even on the slide. We can see that boy who's trying to focus on his own finger, and he's trying to basically focus on it. So as and how this finger is going to come closer and closer to the eyes will begin to turn inwards, and as and how this finger is going to start moving away from the eyes, the convergence of the eyes will start decreasing. So this was all about the convergence. Now, of course, coming to the next one, which is the last one, which is accommodation. Now, what is accommodation? Accommodation refers to a process by which we focus the image on the retina with the help of ciliary muscles. So now basically these ciliary muscles are actually responsible for changing the thickness of the lens of the eye. Sometimes the lens of the eye is going to flatten, and sometimes the lens of the eye is going to thicken, you know. Now, when the object gets away more than 2 meters away, the ciliary muscle is going to relax. When the ciliary muscle is going to relax, the lens, is going to flatten, you know. And as the object is going to begin to start moving nearer to the eyes, the ciliary muscles are going to contract, and as and how the ciliary muscles contract, the lens, is going to thicken. The thickness of the lens is going to increase. So of course, when we talk about the signal, about of course the degree of contraction of the muscle that is sent to the brain, and that is going to provide the cue, you know for the distance, or it's going to be like an indicator for the distance. So this was all about the binocular cues, which are also called the physiological cues. We talked about the retinal or binocular disparity. We talked about convergence, and of course we talked about accommodation. Thank you so much, children.